Good morning, everyone. My name is Xingjie Chen. I'm from ACGUW, and I'm a PhD student. My supervisors are Professor Phil Deit and Dr. Daniel Kompovin. So I'm so happy to be here to introduce my project to you. The title of my project is the utilization of mine waste in the Shotcrete for underground support. So I will introduce my project from these aspects. The first aspect is the aim and goals of my project. The aim of my project is to develop a sustainable solution to the mining industry's issue of reusing the mine waste. And there are three goals. The first goal is to replace the sand with the tailings in the Shotcrete. And this is the primary goal that I would like to achieve. And after achieving that goal, I will try to replace the gravels with the waste rock and then to further reduce the cement. I would like to introduce the problems and the significance of my project. So nowadays in the Western Australia, we know that a lot of the mine waste has been produced and generated, including the mine tailings and mine waste rock. And this has resulted in a series of the environmental issues, and they are occupied on the surface, and a lot of the land has been occupied. This leads to the big maintenance and monitoring burden to the mining industry. And on the other hand, Shotcrete is widely used in the underground support. So among all the ingredients of the Shotcrete, the aggregates accounts for the largest proportion of the Shotcrete mix, while the cement accounts for a smaller proportion but costs most. So it is important if we could reduce the cost of the aggregates and the cement. Specifically, we use the sand as the fine aggregate in the Shotcrete. But in remote locations, the local sand is often not suitable for the Shotcrete, so the sand is often chucked in, and this could be a considerable expense for the mining companies. My project will deliver the environmental and economic benefits to the society. And for the environmental aspects, I will try to minimize the mine waste by reusing the mine tailings to replace the sand. And this can reduce some potential risks such as the risk of the pollution from the groundwater, and the soil because of the release of the toxic and heavy metals from the mine waste. And also, we can reduce some risks of the failure of the tailing dams, and this can threaten the people's lives directly. And apart from that, we can deliver some economic benefits for both mining companies and Shotcrete companies. For mining companies, you can reduce your costs for the rehabilitation and the costs for the environmental bonds. And for the Shotcrete companies, the production costs can directly cut down. And I'd like to introduce the background of this project. Some other scholars have done some work in this area of the use of the mine waste, including the mine tailings and mine waste rock. And some use the tailings as the fine aggregates in the concrete. This is an example. And this scholar have used the local Western Australian iron ore tailings to replace the sand in the concrete. And we can see that the compressive strength, it is comparable. It's very satisfactory and is higher than the normal aggregates concrete. And some other scholars have also done some work, and their results are also satisfactory, but we can see some potential issues. That is the increase of the water demand and the decrease of the slump. This could be result in another issue of that, the decrease of the workability. This may not be a big problem if we use them in the concrete, but it could be a big issue if we use the tailings in the Shotcrete, because the workability is essential for Shotcrete. So we need to ensure enough workability. So we need to pay attention to this area if we use the tailings as a fine aggregates in the Shotcrete. And also, the water demand is also an issue because it's harder to get the potable water in the underground. It's not so easy as in the civil constructions. And I've also done some work in the utilization of the tailings as the cementitious materials in the concrete in my master study. But this is not a conventional way for us to use the tailings in the shotcrete or concrete. We can try it if we have achieved the first goal and the second goal when we have replaced the sand and the waste rock with the tailings. And some other scholars have done some preliminary work on the use of the tailings in the shotcrete. But we can see that the compressive strength, this is just 12 megapascal, and this is 33 megapascal. And the industrial requirement is 40 megapascal. So the 12 megapascal is far from meeting the industrial requirements, but we can still see the potential of the improvement. So that's why I'm going to do this study to use the tailings to replace aggregates in the shotcrete. And some scholars have done some work in the utilization of waste rock to replace the coarse aggregates in concrete. We can see that this is the normal concrete, and these are the concrete using the waste rock, and we can see that the compressive strength is comparable, it's satisfactory. However, we can see the slump. The slump decreased due to the use of the waste rock. So this could be an issue if we use the waste rock in the shotcrete. And again, it could be an issue of the workability of the shotcrete if we use the waste rock in the shotcrete. I'm going to do this project with the shotcrete mix design to design the shotcrete. And usually in the shotcrete, the conventional ingredients include the cement, the coarse aggregate, and sand. Usually sand includes the coarse sand and the fine sand, and mixtures and water. I will do this project via two aspects. One is to use the AI technique, and one is to conduct experiments. Many of you may not be aware of how AI can be used in this project, such like this. So I'm going to give you an example of how the AI is used in the concrete. So this is the process of the use of AI in the concrete. The first step is to build the database, and they collected the data and then clean the data and then build the data set. The second step is to use the ANN method. The ANN method is the artificial neural networks. So this method can be used to estimate the strength of the concrete based on the amount of the main components of the concrete mix. And after they've got the optimal ANN method, they will simplify it into an equation. And they use this equation in the practical engineering industries, because they can use this equation for the concrete compressive strength estimation, and this can serve as a tool for the concrete mix recipe check. So for the database building, the first step is to collect the data. So they adopted these parameters in the data set, including the compressive strength and the cement, water, sand, aggregates. And they put the compressive strength as the output parameter, and the other four as the input parameter. So because we need to build the database and to develop the model. So these four parameters are as the input parameters, and this is the output parameter. And this is the ranges of the input features. And then they collect the data, they clean the data. Why? Because sometimes the data includes some inaccurate, incomplete, and irrelevant data, and they exclude them. They exclude about 10% of the data, and the rest of the data are divided into the 3 subsets. One is the training subset, and the training subset is used to create the neural network. And the second one is the selection dataset. The dataset is used to adjust the parameters of the network. And the other is the testing dataset. This is used to evaluate the efficiency of the network. And this is the scatter plots of the target variable versus the input variables. The vertical axis is the compressive strength, and the horizontal axis is the amount of the input variables, like the cement, water, fine aggregate, and the coarse aggregate. And after collected data, they use the ANN method. The ANN is the artificial neural network, is a machine learning method. And this is a simulation of the mathematical model of the biological neural network. This is the initially used architecture of the ANN they adopted. And this is the finally used architecture of the ANN. We can see that the CWFACA, and this means the cement, water, fine aggregate, and the coarse aggregate. This column is the input parameters, is input layers. And also the CC means the compressive strength. This is the output layer. Usually, for the ANN method, there are 3 kind of layers. One is the input layer, one is the output layer, and another is the hidden layers. Hidden layers usually is the complexity of the model is expressed by the hidden layers. So more of the hidden layers means this is more complex of the model. And we can see that in their case, they use 3 hidden layers. And the finally used architecture of the ANN is the optimal ANN model. They have optimized with the machine learning. So we can see that the neurons are more than the initial. And they use the ANN to analysis, and they calculate the linear correlation and determine a correlation matrix for the analysis. And they also assess the input contribution, assess the impact of individual variables on the output results, which is the compressive strength. And we can see this figure. The cement, the input contribution of the cement is over 1, which means it has more contribution to the compressive strength. And we can see that cement is the most important parameter in the concrete mix design. So we can do the similar thing in the Shotcrete mix design with the use of AI. We can figure out what is the most important and sensitive parameter in the Shotcrete mix design, just like this. And then they express the ANN by equations and simplify the formula. And this is the formula that they have simplified. Yes, but it's true. Because the original thing that they've got is the ANN method, it's the code. And then they express the code into the formula, the equations. There are 15 equations they've got. So now simplify into one formula. So it's good. It's pretty good. And then they use this formula to compress to do the compression between the designed compressive strength and the calculated strength with this from the machine learning formula. And we can see that the result, although for the design strength of 50 megapascal or higher is not so satisfactory, but below the 50 megapascal, we can see that the 40 megapascal and 30 megapascal, 20, 10, with this kind of design strength, this formula is satisfactory. is pretty good. So in my project, we can do the similar thing, that we can make build up a AI model, and then optimize it, and then simplify it with the formula, and we can use this kind of formula for our new recipes. So industry people, you can also use this kind of formula. You just input your parameters like such as the cement, the fine aggregates, and the coarse aggregates, the water, the amounts of them, and then you can predict the compressive strength, and then you can know what kind of it's much better for you to adjust the proportions, and it's easy for you to do that thing, because usually we do this via the experiments. The time is cost, and also the cost, the production cost is high. So it could be used in the practical engineering areas. We can do the similar thing. But notwithstanding in the concrete work, we got just 4 parameters, major parameters. But in Shotcrete, we believe that we need the data for the following is much more, because Shotcrete is more complex than the concrete. And these are the parameters initially adopted. And now, at the moment, I'm collecting the data from the literature, the lab, and industry. And this is what I'm calling for assistance, because I need to collect data from you, from industry people, so that we can work together to build up this model, so that we can use the model afterwards, and we can all benefit from it. And beside the use of AI technique, I also conduct the experiments. I collect tailing samples from different mine sites. I'm aiming to investigate the tailings, the feasibility of using the tailings in the Shotcrete from different mine sites. So at the moment, I have received 4 tailings examples from the Nickel West Leinster and the Down Thunderbox and Wallaby and Golden Grove. And I'm now still looking for more tailings. So if you're interested in my project, you can contact me for this. And I will investigate the properties of the tailing samples via their chemical and physical properties, because these are the parameters which influence the performance of the Shotcrete. And I will do the lab trials and the tests. And after the lab trials, I will do the field trial in the underground site. And so I'm calling for assistance in the 2 aspects. One is the data for AI models. So as I have mentioned, that I need the Shotcrete mix designs and the corresponding Shotcrete performance. And I will keep all of this data from your side confidential. And the second aspect is that the tailing samples for the experiment. So if you are interested in it, you can participate in my project. And this is my contacts. Thank you very much. Any questions? Thank you.